So let's go see what the challenge was to the parallel postulate of Euclidean geometry. Okay? So if we were to put a summary of the parallel postulate up here, okay? Parallel postulate. And in the middle, we're going to put how Euclidean geometry looks at it. Draw a little picture of it. Okay, we'll put a box around that. By the way, Euclidean geometry is the main geometry everybody uses. It works in our space. Everything is accepted as being true. It all works. Been using it for thousands of years. Now, the little picture we're going to use looks like this. We have two straight lines intersected by a third line in such a way that the third line makes right angles with both of those. The two lines that the third line intersects never meet. Now there is another type of geometry. We're going to call it elliptic. Didn't look too good there. Elliptic geometry. Okay? Now the picture that we would draw of it for the parallel postulate looks like this. If we have two lines, because elliptic geometry looks like this, we can intersect those two lines at points with a third line where it is perpendicular. The third line is perpendicular to those two lines, and those lines are always going to meet. Okay? In our honors classes, we'll get into that a little bit later on in the year so you can see what it is. But basically what we're dealing with, we're no longer dealing with straight lines, we're dealing with curved lines, or curved lines that always meet somewhere. But at some point we can intersect them with a line that is perpendicular at that point with those two lines. Okay? We're not going to use this. People use it for multiple things. Use it for spheres like the Earth, those kinds of things. Now the other one, geometry, that we have is called hyperbolic geometry. And you'll see these terms on tests or whatever else that people have, and you'll see some of the assumptions that they have, and they'll make those assumptions, they'll state the assumptions, and then want you to pick the best example of what those assumptions mean. Now, if Euclidean geometry says these two lines never meet and they're straight, elliptic geometry means they act like an ellipse, in other words, always going to meet. What do you think hyperbolic geometry says? Opposite of elliptic, they never meet. So basically, we have two lines that look like this when we intersect them with a third line in such a way that at the point of intersection of both of those lines, the third line is perpendicular or creates right angles, then basically hyperbolic geometry says those lines will never meet and they never touch. And on top of that, there's several lines that go through those points that will never meet and never touch. So what you see is basically elliptic geometry comes back and says, sorry Euclid, we don't agree with this. There's not just one set of lines here, and all the lines that go through those points are always going to touch because they all bend together. Okay? Now, hyperbolic geometry says the other, says, sorry Euclid, there's not just one set of lines that would be parallel there. There are multiple that and would never touch. There are multiple sets of lines that would never touch because we could simply come up here and describe another set that went through the very same point like that, and another one that came through like so, and so forth, and we could describe multiples of them. Okay? So this is the main challenge that the parallel postulate has had, the fifth postulate of Euclidean geometry. Okay? And the challenges are elliptic, hyperbolic, and there's many others. However, major challenge first. Major challenge appeared 1900, okay, AD. All right? Euclid was born in 300 BC. He wrote his book 300 BC in that neighborhood. So it was like 2,000, 2,200 years before there was a major challenge to parallel postulate, the fifth postulate of Euclidean geometry. Now, go over these because you're going to see them on a test. Not necessarily elliptic in all those concepts, not necessarily hyperbolic, but basically you're going to be seeing those terms. All right?